Welcome, everyone. Today, we are diving into one of the most critical skills for an AI solution architect, evaluating the costs and benefits by creating a rigorous ROI analysis for your proposed AI-powered business process. Let's get started. Welcome to the first slide, where we introduce the foundational concept of AI ROI analysis. What exactly is this? Creating a rigorous ROI analysis is essential for evaluating whether an AI solution delivers measurable business value. The basics involve looking at both the hard financial savings like productivity metrics and the total costs required to build and maintain the agent. Why must we do this? AI adoption often fails because organizations either overestimate their productivity gains or severely underestimate their operational and maintenance costs. Therefore, our analysis cannot just be a wild guess. How do we approach this? We apply a structured methodology to evaluate the ROI of a proposed AI solution tailored to a specific business process. In our deep dive, we will see that this ROI model must be packaged carefully. It must translate estimated time savings into actual financial benefits that align directly to enterprise KPIs, ensuring our final pitch is fully defensible. Let's look at the foundational flowchart on your screen. This diagram illustrates the high-level journey of our ROI analysis. On the far left, we begin by defining a clear, defensible scope. This means isolating a specific, measurable business process rather than trying to measure AI value vaguely across the whole company. From there, the flow splits into our two primary measurement tracks, the annual benefit and the total cost of ownership, or TCO. The top track represents the value generated, such as time saved and error reduction. The bottom track represents all the costs required to build, run, and govern the solution. Finally, these two tracks converge on the right side into the net benefit and ROI percentage. This visual makes it easy to perceive that true ROI is a balancing act. You cannot claim success by only looking at the benefits track while ignoring the complex TCO track beneath it. Moving to slide 2, we must define our ROI scope and establish a baseline. What does this mean? We are defining a defensible ROI scope for an AI solution mapped to a single business process. You should never try to calculate ROI for general AI use across an enterprise. For the basics, you must baseline the current process to identify exactly where the waste is today. Why is this critical? Because setting a narrow scope with clear baselines and guardrails prevents vague estimates and protects you from scope creep. How do we do this practically? We identify the specific AI intervention, mapping out exactly what the new agent will automate or augment in the workflow. Diving deeper, we focus heavily on an agent-level savings model. By analyzing the time saved on a per-run and per-tool basis, we can isolate the AI's exact contribution and ensure our savings calculations are grounded in the mechanical reality of the process. Let's walk through this process mapping diagram. On the far left, we start with the current process baseline. This is our before picture. We then move to identify manual waste, which is where we locate the specific bottlenecks, delays, or repetitive tasks that drag down efficiency. Next, we hit the Map AI Intervention node. This is where we clearly define what the copilot or custom agent is going to do to solve that waste. This flows into the agent-level savings model, representing our strategy to measure the exact impact per task execution. Finally, this culminates in a quantifiable process improvement on the right. By following this visual pipeline, we guarantee that our ROI is tethered to a real, measurable business workflow, rather than abstract productivity claims. On slide 3, we tackle quantifying benefits and savings. What is our goal here? We are actively quantifying the specific time and cost savings the AI solution will generate. The basics of this step involve calculating the gross benefit, which is a combination of direct time savings, financial savings from error avoidance, and increases in throughput capacity. Why must we do this math so rigorously? Because executives need us to translate raw productivity metrics into concrete financial benefits that align directly to enterprise KPIs. How do we calculate this? The formula requires multiplying the minutes saved per run by the monthly volume of tasks, the expected user adoption rate, and the hourly labor rate of the employees involved. For a deep dive, let's look at an illustrative example. If an agent saves 1.8 minutes per message on a volume of 50,000 messages, assuming a 60% routing adoption and a $45 per hour labor rate, the annual savings calculates to roughly $486,000. Take a look at the benefits calculation diagram on your screen. At the top, we have 3 independent input nodes feeding into our central calculation. We have the minutes saved per run, the monthly task volume and adoption rate, and the hourly labor rate. These are the three critical multipliers. When combined, they flow directly into the gross annual benefit node. But notice the two nodes extending below it, error avoidance and throughput capacity. This highlights that time saved is not the only financial win. If the AI reduces costly manual errors or allows the existing team to handle a 20% increase in work volume without hiring more staff, those values are added to the gross benefit. This visual reminds us that a comprehensive ROI captures both direct time recovery and indirect operational enhancements. Slide 4 introduces the counterbalance to benefits, modeling total cost of ownership, or TCO. What is this? It is the process of building a complete ROI model that balances those gross benefits against the comprehensive total cost of ownership. The basics dictate that TCO must include your initial, one-time deployment costs, as well as your recurring, monthly operational run rates. Why is this so vital? Building a highly transparent TCO view ensures that your ROI is durable and realistic beyond the pilot phase. Without TCO, your ROI is just a vanity metric. How do we structure this? We evaluate costs strictly across 5 domains: infrastructure, development and integration, data quality and preparation, expertise and staffing, and operations and licensing. Diving deeper, architects frequently underestimate the data quality domain. You must budget for data cleansing, grounding and indexing costs, ongoing refresh schedules, and continuous drift monitoring to keep the AI accurate. Let's examine the TCO framework diagram. Notice the 5 distinct cost pillars pouring into the central, total cost of ownership, node at the bottom. On the far left, we have infrastructure, which covers compute for inference, storage, and networking. Next is development and integration, covering orchestration and security testing. The middle pillar is data quality and drift monitoring, highlighting the ongoing cost of keeping the AI's knowledge base clean and relevant. Next is expertise and MLOps staffing, representing the human cost of architects and change management. Finally, operations and licensing covers the recurring software fees and telemetry monitoring. This visual clearly communicates to leadership that AI is not a one-time software purchase. It is a living, breathing system with continuous operational costs across 5 distinct domains. Now we move to slide 5, calculating the financial metrics. What are we doing here? We are applying standard financial formulas to determine the true net value of the AI investment. The basics are straightforward. The net benefit is calculated simply by subtracting your annual TCO from your gross annual benefit. Why do we present the data this way? Because these are the exact metrics required to prove the value-to-cost ratio to your financial stakeholders and executive leadership. How do we calculate the final ROI percentage? You calculate the ROI percentage by dividing the net benefit by the annual TCO and then multiplying by 100. For our deep dive, we must also present the payback period. This tells leadership how fast the investment breaks even. The payback period, expressed in months, is calculated by dividing your initial one-time cost by your net monthly benefit. These 3 numbers, net benefit, ROI percent, and payback, form the core of your business case. This diagram provides a clear visual representation of our financial math. On the top track, we take our gross annual benefit and subtract the annual TCO to arrive at our net benefit. From that net benefit node, an arrow points to ROI percent, showing that we divide the net gain by our ongoing costs to get our return rate. On the bottom track, we have a separate calculation for time to value. We take the initial one-time cost, the money spent before the agent ever goes live, and divide it by the net monthly benefit to calculate the payback months. By displaying the math in this flowchart, stakeholders can easily perceive how their upfront capital investment and ongoing operational budgets relate directly to the projected timeline for profitability. Slide 6 introduces a crucial architectural practice, adding sensitivity and risk bands. What is this? It is the practice of creating a range of potential outcomes to account for the probabilistic nature of AI and unpredictable user adoption. The basics require you to create optimistic, expected, and conservative cases for your ROI forecast. Why do we do this instead of providing a single number? Because by showing ranges, stakeholders can see both the potential upside and the inherent risk, which dramatically builds trust in your architectural projections. How is this executed? You duplicate your math model and vary key inputs, specifically the user adoption rate, the estimated minutes saved per run, and the mix of labor rates impacted. For a deep dive, you should anchor these sensitivity bands using recent field research on knowledge worker productivity to justify your assumptions. However, always ensure that your own organizational telemetry remains the primary driver of the model. Let's explore this sensitivity analysis tree. It starts at the top with our single base ROI model. From there, we branch out into 3 distinct scenarios: the optimistic case, the expected case, and the conservative case. Notice the conditions attached to the arrows. The optimistic path assumes high adoption and high time saved, leading to maximum ROI. The expected path assumes we hit our targets, leading to baseline ROI. Critically, the conservative path on the right assumes low adoption or a high error rate that requires human rework, leading to a minimum ROI. By presenting this tree to executives, you demonstrate that you have thoroughly pressure-tested the business case against failure modes, proving that, even under conservative conditions, the AI solution remains a sound investment. Our 7th slide focuses on presentation, packaging the executive one-slide summary. What is this deliverable? It is a concise summary that decision-makers can easily review and act upon in a single glance. The basics of this slide are non-negotiable. It must clearly state the problem and scope, the specific AI intervention, the measured impact, and the final financials. Why do we condense complex math into one slide? Because executives need a consolidated, highly transparent view of value versus cost to confidently approve funding. How do you structure the close? You must end the slide with a clear, actionable decision prompt, such as pilot for 8 weeks with success criteria X and scale to Y units on pass. Diving deeper, do not hide the risks. Explicitly document your confidence levels and the risks involved, acknowledging the sensitivity bands and key assumptions you made regarding adoption and TCO. Complete transparency wins approvals. Look at the layout diagram on your screen, which represents the ideal structure of your executive one-pager. Inside the boundary box, the flow reads top to bottom, exactly how an executive processes a pitch. It starts with problem and scope, where the waste is today. It moves to AI intervention, what the agent will actually do. Next is measured impact, detailing the minutes saved and quality lift. This is immediately followed by financials, showcasing the ROI % and payback timeline. Crucially, before the final ask, the flow inserts confidence and risks, proving you have evaluated the downsides. Only then does it culminate in the final node, decision, 8-week pilot approval. This logical flow prevents confusion and directly connects the business problem to the financial request. In our final slide, we address continuous measurement and analytics. What does this mean? It means using real-world operational data to validate and constantly update your initial ROI assumptions. The basics involve actively monitoring Copilot Studio analytics, specifically tracking active users, average session durations, and task completion rates. Why is this a mandatory phase? Because continuous measurement is the only way to prove the ongoing ROI of the agent, and it highlights exactly where prompts or data sources need refinement. How do we operationalize this? You must actively replace your initial mathematical assumptions with actual savings telemetry as it accrues during your 8-week pilot. Taking a deep dive into cost management, you must rigorously track the token consumption cost per successful outcome. This guarantees that your recurring operational TCO remains perfectly aligned with your approved budget, ensuring long-term financial success. Our final diagram illustrates the continuous measurement loop. We start on the left with our projected ROI assumptions, the math we just pitched. This leads into the pilot deployment. As the pilot runs, we move to capture Copilot analytics, pulling real data on usage and token costs. This data hits a decision node, compare versus baseline. If the real-world data shows higher costs or lower adoption, we take the top path to tune prompts and TCO, fixing the AI before scaling. However, if the targets are met, we take the bottom path to replace assumptions with actuals, firming up our business case with hard evidence. Finally, this validated, real-world ROI allows us to safely scale to production. This visual proves that ROI is not a static document, but a dynamic, data-driven lifecycle.